All right, so this talk is from zero to hero, how to get your private cloud project to take off. First, let's get to the next slide. Yeah, maybe. Yeah, that one works. So first, a few words about myself. Like Stefano said, I'm Maxime. I'm a cloud consultant. I work with companies of all sizes, small and big, to get public and private clouds project going. So usually it's a combination of Openstack. I mean, we are the Openstack days, so of course. Ceph, Kubernetes, and some DevOps platform to accelerate the development processes and accelerate the time to market when they are developing applications. So that's like the traditional use case that I work with. But that's enough about myself. But before we go into the content, the slides are already available online. So there are a few like references and specifications in the slides. So you don't need to take photos of the slides. Just check it out online, and you can follow along if you want. The agenda for the presentation is first we'll start with the hardware, then we'll go into deployment method, and then we'll speak about the more fluffy stuff, the strategy and do's and don'ts around private cloud for OpenStack. So it's like from the lower level to the higher level agenda. The talk is from zero to hero. So what do I mean by from zero? So I'll assume that you have some general knowledge about IT and that you've heard about OpenStack and cloud. You have opportunities this morning to meet a lot of people in the marketplace. So I guess you already have a good idea what the cloud and OpenStack is. We can start with the traditional OpenStack architecture for a private cloud of not too big size, let's say. This is like a solid base that you are able to scale. So on the left-hand side, you have your controllers, and that's where your OpenStack services run. This is where your users will talk with APIs, and the controllers will, or the OpenStack services will make the magic happen into the backend. And that's in the network fabric, into the compute nodes, and into the storage. So that's the traditional setup. On the compute node side, the recommended hypervisor is KVM. It's by far the most popular one on the OpenStack user survey. So if you're doing a private cloud, it's going to be much easier for you to use KVM than to use anything else. You'll have a bigger community and bigger support around that. And it's similar thinking around the storage nodes. The user survey clearly shows that the Ceph backend is the most popular for storage. So if you're doing a private cloud, you're better off using Ceph than using vendor-specific things or DIY stuff. So that's that. On the network fabric side, it's detailed in the slides later on. I'll take the example of a VLAN segmentation, and that's a good place to start, something very simple that everybody knows, and then as you grow, you can move on to VXLAN or something more advanced if you require that. But the idea here is to have a solid base that you will be able to expand as you grow. So this is like a first private cloud setup, basically. So we can dig into the hardware. We'll start with the management switches. Always need some management switches to be able to access the equipment. We'll just need two standard top-of-the-rack 1 gig switches, 48 ports. Those are really cheap switches. We use one for IPMI and one for PXE. So IPMI is your out-of-band management interfaces where you'll be able to remote power cycle your servers and have the monitoring of the hardware. And the PXE network is going to be where you'll do your installation of the server, so you can do everything remote. Here you have plenty of vendors. You have Juniper, Cisco, Arista, EdgeCore. You have, take your pick. Doesn't really matter. They are very simple use here. Just take what you're comfortable with. That's what's most important for this. We have another pair of switches, and those are going to be the more important one, where you have all your data, all your storage traffic, all your customer traffic is going to go there. And here we'll stick to keep things simple, so we'll use industry standard 48 port 10 gig switches. Usually it's based on Broadcom chips for basically all vendors. Using SFP plus interfaces that saves on power and on costs, both on the NIC side and on the switch side. So that's like the standard data fabric we have. We are going to configure them in what some vendors call MLAG, some other vendors they call stacking. So both switches will cooperate to be able to do LACP. And LACP is like aggregation of links, and we'll configure the switches symmetrically. So port 1 on the first switch will be LACP together with port 1 on the second switch. This way you have something very simple. You don't need like super complicated setup here. A few words about the different vendors. Here it's, of course, take what you're comfortable with. So if you already have a lot of expertise in Juniper or in Cisco, maybe it's good to stick with that. But if you are a fresh team, like a fresh project, it can be interesting to use white box switching. So here I put edge core to represent a bit the white box switching approach. So you take a white box switch, and on top of that you use something like Cumulus Linux, and that allows your Linux engineers to be able to manage your switching fabric in the same way as they manage the servers, and that way you can really break the silo and have the same processes and the same tooling across the stack between the storage, the virtualization, and the network. So that's something really interesting if you have the opportunity to do so. That's really interesting. For the servers, we're still in the hardware. We have 3.5 types of servers that we need. We're going to need controllers. We need at least 3 of those, and here I say 3 plus 1 because we'll just take an extra server for deploying the environment. So that's where your PXE server will be, and this is where you will have your deployment tool that will install all the rest. So it's kind of like a bootstrap or a seed for your environment. So we'll just take the same specs as for the controllers to just keep things simple. And you'll also need some compute servers, of course, where your VMs will run. So this is your traditional hypervisors. It doesn't really make sense to do OpenStack if you just have a single hypervisor. So you're going to need at least like a certain amount. Maybe 4, maybe 8 is a good place to start to make any form of economical sense. You have a lot of overhead with the controllers and so on that you need to spread among different compute nodes. So this is like a place to start, a minimum, and then you scale out as you need, you add more capacity. So that's it for the compute and the controllers. On the storage front, it's split up into two subtypes, the block storage and the object storage. Block storage is basically mandatory or required for most private cloud deployments. And in Ceph, since the recommended replication is factor 3, we're going to need at least 3 servers for block storage. And that's good for POC, but as you go to production, you're going to want to have a bit more than 3 to have more flexibility, have all the auto-healing capabilities and so on. So maybe 4 or 5 is a better spot to be in terms of production, or small-scale production at least. For object storage, this is optional. Some deployments want it, some don't. So if you need it, same story as for block storage. If you don't need it, just don't put any, and you're good to go. So that's it for the servers, the quantities that we have. Then the few slides after we'll go into the specs. I will not read all the specs, but you can check the slides if you really want to know all the CPU information and so on. Every single server will have a similar base, one IPMI port, we connect to IPMI switch, one PXE port, we connect to PXE switch, simple. We have 2 10 gig ports. One port will go to the first switch and the second port to the second switch and configured into an LACP on both ends. This is fairly standard. We'll also use SSDs to have the operating system installed. We put that into a RAID 1 to avoid failures. And here I often get questions, okay, why do you need the SSDs for operating system? Doesn't really matter. Well, a spinning disk, like a small spinning disk, is gonna, like a 500 gigabyte one, will cost you roughly the same as a small SSD. So if you go with an SSD, you get this extra speed and this extra flexibility. It's gonna shorten your maintenance window and give you a little bit more flexibility when you need to, I don't know, install updates or upgrade your system or things like this. A less service window is always better for you operationally and for your customers or consumers. They don't want to spend the whole day in service windows. So some references there. The controllers, it's a standard pizza box, half a U, 1U server. And the only important thing is that it has some specific SSDs to store the database, metrics, and things like this. And those needs to be write-intensive types SSDs, since database applications. That's what matters there. For the compute nodes, we can use the same platform, the same pizza box. We're just going to bump up the amount of CPUs and bump up the amount of RAM we put into them, since this is hypervisors. We want to have good density, so we can have a good cost structure in the end for the public, for the private cloud we're doing. 256 or 512 gigs of RAM, that depends on you. If you go with 256, just make sure you're able to upgrade later on without tearing out all the memory sticks. Yeah, so let me come to that one. That's right. So here storage, if it's your first private cloud deployment, my recommendation is don't put any ephemeral storage just yet. It's going to be more successful for your project to use the block storage, like the Cinder storage, than to use the ephemeral storage, because it's a shift in culture compared to legacy application, and that gives you the that avoids some mistakes that maybe you will have some servers that will use ephemeral storage, but you didn't know about it, or somebody was not aware that this is ephemeral, and then you lose data. So especially if it's your first private cloud, it's important to use the persistent storage. And then as you scale out, as your organization gains expertise, then you add ephemeral storage as an option. So that's really the strategy there. We still have the operating system drives that I mentioned in the previous slides. Block storage, this is even cheaper servers. One-socket servers to avoid problems with performance in NUMA topologies. And what's a bit more costly is the SSDs. So the platform is very cheap, but the SSDs are a bit more expensive. Here the reasoning is that for block storage you want to have good performance, so you can do an all-flash system. Nowadays it's not that expensive compared to a flash accelerated system, so it makes sense economically to do that. You have different vendors that have this type of boxes out there. For the object storage, this is optional. This is going to be a 2U box with 12 spinning disk and 1 NVMe for journaling. Fairly standard setup for Ceph. You can find many vendors providing this type of platform. If you decide to go with one vendor or the other, you could change the controllers from Dell and compute nodes from Supermicro, object storage from HP. It's up to you what you want. Doesn't matter. It's all commodity hardware. Doesn't matter for OpenStack as long as it works. Take what you're comfortable with. In terms of deployment methods, so now we move from the hardware to, okay, how do we provision this hardware? There are a few deployment methods out there. There are quite many. OpenStack is like a complex system, and you don't want to deploy that manually. You don't want to have like engineers configuring all your servers manually and all that stuff. That's going to be a nightmare. You have the human factor. There are so many things that could go wrong. You want to have like an automated thing. There used to be, or there is Project Fuel that is or was a popular option for first-timer to get into. It was very attractive because it's like an ISO file that you install, and then you have a UI, and then you like next, and then you have a working cloud. Takes care of installing the operating system, configuring all the OpenStack services, and so on. So that's nice. On the downside, it kind of stopped the development on it. So people who have used that, they're a bit stuck now. You have very little flexibility because you have a UI. You don't have so many customization options, and it's basically very difficult to upgrade, to get out of. So if you decide to use Fuel, it's more like something that's extremely short-lived, just get a feeling of OpenStack, but that's it. Don't use that for any serious thing. Even a POC might not be appropriate for that. So you have more appropriate tools nowadays. You have Openstack Ansible, which has a very large user base. That's an OpenStack project. It uses popular tools, namely Ansible and LXC, to deploy the control plane of OpenStack. It's really flexible because you can overwrite all the configuration options if you want to into a supported way. So your customization will stay version after version. So that's really important. You don't want to lose your custom things when you upgrade, for example. It supports upgrades, so that's used to be a big pain in OpenStack world, and so it's something to look out for. On the downside, it doesn't take care of the operating system setup for you, so it doesn't doesn't install the operating system. So you need to have something else for that you probably already have in place in your organization somewhere, how you already install operating system. So maybe you can use the same thing. Up to you to have a look at that. You have another project called Kola, and that's fairly similar to OpenStack Ansible. It just replaces LXC with Docker containers, and that's supposed to make upgrades even easier than OpenStack Ansible. It's a bit newer, so maybe it doesn't have the same maturity, but if you have a good skill set in a Docker, maybe it's worth to check out Kola, and if you have a good skill set in Ansible, maybe you're better off with OpenStack Ansible. So that's like the two production-ready deployment method you have right now. Of course, each vendor has their own deployment method. You maybe talk to a few of them in the marketplace. So no, those are the open source deployment method. Each vendor has their customized thing as well. Now we can go into operations, because deploying OpenStack is just maybe the easy part. You need to keep it running, you need to upgrade it, you need to monitor it, and to have the capacity management around it. The most common question is around monitoring. What do I need to monitor into my OpenStack deployment? So first and foremost, you need to have your standard monitoring stuff, what you monitor on every Linux server, your CPU, your disk, your RAM, your network traffic, your services, what services are up, down, your hardware probes. You want to be aware when you have a system-level problem. So that you should already have something like this in your organization, and just move that into your for your private cloud project. The OpenStack specific things are monitoring things like the API endpoint status, the API error rate. So if customers are getting a lot of errors, you should be able to react and detect that. You want to monitor your capacity. Never fun to run out of capacity, and having customers to tell you about it. You want to know about it in advance. You want to monitor the status of different things, and most importantly, you want to monitor your backup jobs, because you need to back up your OpenStack database, your user list, and all that stuff. So that's really important to have that as well into the monitoring strategy. For the storage, so for Ceph, we also need to monitor the cluster status, the smart data, the endurance of the SSDs. You don't want your SSDs to run out of writes in the middle of a migration, for example, so that you need to monitor, and your capacity as well, of course. So that's the bare minimum you need to monitor, and then it depends a bit on your usage of OpenStack. You can add a lot of monitoring bells and whistles there. How to monitor depends a bit of what you already have in place. What's most important is that you have graphing capabilities. So tools like Guyot doesn't have graphing capabilities out of the box, so you need to make sure that you have graphing capabilities. Otherwise, your monitoring information will not be in context, and you will not be able to know, is this a spike in my capacity, or is this a long-term trend? So it's extremely important to have these graphing capabilities. Just use whatever you're familiar with. Here I put a few names. Maybe Zabbix Prometheus is more modern tools than Guyot, if you don't have anything in place already. All right, that's it for the monitoring. Now we have the capacity management. We need to update a little bit the capacity management processes we have from the legacy environment. So in the legacy environment, maybe you would plan a lot ahead of time. in OpenStack, since you have this flexibility for the consumers, you also need to have this flexibility for the capacity management processes. So don't buy equipment today that you will use only in a few years. Just buy it when you need it. So buy the capacity just in time is the idea. And you want to minimize your unused capacity. Otherwise, you'll sit on a lot of resources that are not used and not relevant for anybody, basically. So that's thinking you need to have around capacity management. Now to the fluffy stuff around strategy and do's and don'ts. So this is like experience gathered from different projects. What are the common pitfalls and positive and negative things that happen? So usually people, when they start their first private cloud project, they think that they have a unique use case and they want to have this super specific setup that's targeted only to them, and that's gonna be basically a nightmare to operate and to upgrade or to find people to work with. So as much as possible, try to see what the community is doing, try to see what's the consensus, and go with that. You want to you don't want to solve only one person's problem. You want to address many units in your business. So that's important. A lot of private cloud projects also have problems with promises or over-promising. OpenStack is a lot of things, but it will not fix the organization problem you have. So if your organization has some culture problems or I don't know, something like this, it will not address those. You need to address those in parallel as your technology stack. Another big pitfall is around reusing the legacy team. Let's say you have a VMware and a SAN team, and you ask them, okay, now we have this OpenStack thing, please install it for us. And that never works out because it's just a different culture. People who have worked in those old platforms, you can't just drag and drop into the new one. You need to have some training at least, or having some more experienced people to guide it in. So usually that's a difficulty. On the things that you should do and not avoid is to set realistic goals. That's true for any type of IT project. You want to have realistic goals, otherwise you will not be successful. It's better to under-promise and over-deliver than the opposite. So this way you will be more successful. So start with a general purpose cloud, and then as you get more experience, then you can customize your cloud to be more specific to your business. And you can see if you really need these customizations. Start small-ish. You don't want to start too small, but don't start too big either. So maybe a team of 5-6 people is a good spot to have, and a cloud of maybe 20 to 40 servers is a good place to be. Don't start 500 to start with. You need to test the waters first, and that's true in IT in general. Test first before you go large scale. So this is similar approach. A lot of private cloud projects either start too small or they start too big. One guy is not enough, and 500 guys, you will never get there. If you have one takeaway is, I think, to break the silo. You don't want to have your private cloud project to end up in the storage team, virtualization team, network team. You really want to have cross-functional individuals and very skilled Linux engineers or full-stack engineers that are able to help across the stack and track down or support your infrastructure regardless. You don't want to end up in this ping pong between teams, basically. So that's it for the takeaways, basically. And now we come to the to-hero part. So at the beginning we had this general stuff. What's the target of the talk is for you to have some elements that you can bring back to your organization, and should be enough to get a functional IaaS cloud. So that's infrastructure as a service. That's a solid base that you can build upon. So maybe you do some paths later on. So platform as a service, you can add some database as a service or something like this. But you need a strong base to start with. You need to learn how to walk before you can run, right? And it should be a cost structure somewhat similar to public cloud. and should deliver you the similar flexibility to public cloud. That depends on your organization. What's the FTE cost? What's your data center cost, and all that, of course. But it should be somewhat similar to an internal public cloud. That's basically the idea. And that's it for the presentation. Thanks, everybody. The slides are online if you want to check out. And I think it's time for questions.
Yes, exactly. Thank you, Maxime.
Right on time.
Right on time. Perfect.
Yes.
Perfect. Perfect. Is there any question to Maxime? Sorry, I'm in the middle. Okay, one. Okay, here it comes.
So, I have one question about, do you have any recommendation on strategy for backup and recovery of?
All right, so you have two elements there for backup and recovery. You have the backup and recovery of the OpenStack control plane itself and the applications. So the applications, that's up to them, up to each application to see what's your strategy there. And for the OpenStack control plane, it's important to back up all the services that have state. So things like database, all that stuff. You need to have nightly backups or hourly backups based on your use case. And then you ship that offsite. In case of a disaster, you're able to reinstall everything and put the data back in. So that's the overall strategy for backup. Look where the state is and back that up. So usually it's a MySQL database in case of OpenStack. All right.
Hello. Hi.
Hi.
Actually, you talk about something related to the DevOps things. So do you have any recommendations that how we can mix the team for the fitting into the DevOps environment?
All right. So OpenStack usually provides some form of infrastructure as a service. That's what I've presented here. Then on top of that, you can add, say, Kubernetes or some PaaS solution. For example, there's Project Magnum in OpenStack that allows you to install Docker Swarm, Kubernetes clusters, all that stuff on top of. So this is like one part of the bigger puzzle if you want to do DevOps. And then you do infrastructure as code so that every commit gets a CI pipeline, CI/CD pipeline, and gets sent to your cloud platform, being OpenStack, Kubernetes, Mesos, whatever you want. So that's the idea.
Okay. Is there any other question then? Otherwise, yeah. Okay. But then, thank you very much, Maxime.
Thanks.
Thank you.